Hello, 7th grade. This is lesson 46. Our objective for today is what are rates and how are they used, or how can we use them? A rate is simply a ratio of two different measures. So like 60 miles per 1 hour, or we kind of abbreviate that, say 60 miles per hour. Maybe 23 miles per 1 gallon, 23 miles per gallon. Or maybe 3 books per 2 weeks. So pretty much any kind of units of measure divided by each other will give you a rate. Now, some of the most common ones is whenever you're dealing with distance and travel. So like this one, miles per hour, that's a speed. That's a rate. And so a rate is equal to the distance you travel divided by the amount of time it takes you to go that distance. We abbreviate that, just say R is equal to D over T. Now, if you multiply both sides of this equation by T, you get the distance is equal to the rate times the time. So if you wanted to know how far you went, you could say how fast you went, multiply it by the time, and it would give you the distance. So let's see if we can put some of these formulas and ideas into practice. This is example 1. It says Arnold drove 360 miles from Los Angeles to this place in 6 hours. What was his average rate of speed? So we want to know, on average, how fast was he going? So the speed for this is going to be 390 miles in 6 hours. Now, if we want to know average rate of speed, we only want to say how far he would go in a single hour. So let's see if we can reduce that by saying 390 divided by 6. And we get 65 miles per 1 hour. And you could write it like that if you want, or most of the time we write it as 65 miles per hour. Since that's a common rate there, we have an abbreviation for it. Example 3 said Jared was paid $480 for 30 hours of work. What was Jared's hourly rate of pay? So again, you take how much he was paid and then divide by the number of hours he worked. When you divide that, like the zeros will reduce, 48 divided by 3 gives you $16 per 1 hour, or you could say $16 per hour. Either one of those would be fine. I'll probably say this one. Alright, it says, what is the unit price of a 24-ounce box of cereal priced at $3.60? And this is actually something that I do fairly often whenever I go to a grocery store, is you can compare prices. Sometimes they have a normal size box and they have a family size box. Well, is it actually cheaper to get the family size box? And sometimes if you look at Walmart, there's a little number up in the top left hand corner of that will give you the unit price or the price per ounce. And so sometimes you can say, hey, it'd be cheaper for me to actually buy the smaller box or the bigger box. It's cheaper per ounce. Or you can compare brands, off-brand versus name brand, things like that. So to find out the unit price is just when that denominator is 1. So we're going to say 24 ounces divided by, and actually I want to say price per ounce. I'm mixing you up here. Price per ounce, which means I'm going to say the price is on top, and then I'm going to say the ounce at the bottom. So I'm going to say $3.60 on top, divided by the 24, and this is ounces. So say 3.6 divided by the 24, and you get 0.15 cents, or sorry, $0.15 per ounce. Example 6 says Linda's car holds 12 gallons of fuel and averages 26 miles per gallon. If she starts a 280-mile trip with a full tank of gas, is she likely to reach her destination without needing to refuel? So really what we need to do is we need to figure out how far she can go with these 12 gallons if she's going 26 miles per gallon. So let's remember those formulas. We have two of them. We have distance is equal to rate times time, because if we're looking for a distance, and we have a rate and a time. And then the other one is the rate is equal to the distance over the time. So let's see, what are we looking for? We have gallons, which in this case would be our time. And our miles per gallon, notice it's miles per gallon. So this is going to be our rate. So we have a rate and quote unquote a time, and we're looking for the distance traveled. So let's use this one right here. So we're going to say the distance we can go is going to be the rate, which is 26. Notice there's miles on top, and then we have gallons down here in the bottom for 1 gallon. I'm going to multiply this by 12 gallons, and that's just over 1. That's not a unit rate, it's just saying 12 gallons. So notice their gallons rate will reduce, and we will just need to say 26 times 12, which gives us 312, and my unit on this is just miles. So on her 12 gallons of gas, getting 26 miles per gallon, she can go 312 miles. So the question is, if she can go 312 miles, will she be able to make this trip with 280 mile trip? So the answer would be yes. Yes, she can make that trip without refueling. Alright, number 7. Shelley needs to drive 180 miles from her home near Fort Worth to Austin. If Shelley begins her drive at 9 a.m. and averages 60 miles per hour, when can she expect to arrive in Austin? Alright, so we have two things. We have a distance, 180 miles, and we have a rate, 60 miles per hour. So remember, we have distance is equal to rate times time. And what we're looking for, since we have a distance and we have a rate, we're looking for that time. Time is what we're looking for. The other one we have is the rate is equal to distance over time. So notice neither of those is really time equals. So I'm going to go ahead and just use this first one, distance equal to rate times time. So I'm going to say 180, that's my distance, is equal to the rate, which is 60 miles per hour, 1 hour. I'm going to multiply it by time in hours. So notice those hours will reduce, and I'll just end up with miles equal to miles. So then what I have is 180 is equal to 60t. To solve for t, I'm going to need to divide by 60. This will reduce to become 1, and I will end up with t, or my time, is equal to 3 hours. Now, is my answer 3 hours? Well, no, because it said what time will she arrive, knowing that she left at 9. So what I need to do is I just need to say the 9 hours plus the 3 hours is going to give me 12. So you could say about 12. Or if you want to say about noon, you could do that. But she'd be there around noon, around lunchtime. Alright, example 8. Philip is planning a bicycle tour of the state with some friends. He estimates that they can ride 7 hours each day and average 12 miles per hour. How far does Philip estimate they can ride each day? So this one, we're looking for a distance. How far, right? How far can they ride? So we have a rate, miles per hour, and there was a time in there. Where is it? 7 hours. There we go. So I'm going to use the distance is equal to rate times time. So the distance is going to be the rate, which is 12 miles per 1 hour times the 7 hours. So again, those hours will reduce, and I end up with the distance is equal to 12 times 7, which gives us 84 miles. And that's how far he's estimating they can ride each day. It's 84 miles. Your homework is on page 332. You're going to do the practice set, all the 46s, all the 45s, and 9 more of your choice. Good luck.